And let's see here. It says we're recording. All right, so let me share my screen. Okay, so today is an exciting day. We're finally going to talk about the unit circle. Some of you may have heard of this. So remember, I think that was the first day of class, we said that S is your arc length equals theta times R. So if your radius is 1, then your arc length equals simply the measure of your angle. So if this is the measure of our angle, or if this is, so this is the angle here, pi halves, okay, this round arc here. And if my radius is 1, if we were to straighten out this curve, then that curved straight line, the length would be just the same length as the angle, pi halves. So we could call that t. So we can use this to find real numbers, and this is called the wrapping function, okay? And we're going to find coordinates. So let w be the wrapping function where t is any real number, such as the wrapping function w of t equals the point xy. So it's the point on the unit circle, okay? So remember, in this case, our radius is going to be 1. So normally we would say the sine of t is going to be y over r, but since r is 1, then the sine of t simply equals the y coordinate, okay? The cosine of t is going to equal the x coordinate, and your tangent of t is going to be y over x. Obviously, x cannot be 0 or you have a problem, or it's undefined. Same thing with your reciprocal function. Cosecant of t is 1 over y. Secant of t is 1 over x. Obviously, we got a problem if either of those are 0. And your cotangent of t is x over y. Obviously, y cannot be 0 or it's undefined. Okay?
What is t? How is it different from s?
So t is, you can think of it as your angle. You can think of it just like theta. So t is your angle on the unit circle.
Oh, okay.
So if we're looking at a point xy, remember we're talking about the unit circle. So both x and y have to be less than 1 because your radius is 1, okay? So if we take the point xy, then essentially the values of t, of your arc length t, or your angle t as well, is simply, so x equals the cosine of t, y equals the sine of t. And so you can write x and y in terms of sine and cosine. So given that the cosine of pi thirds equals x over your radius, and your radius is 1, then your cosine is x, okay? So in this case, the cosine of pi thirds, we know that's 1/2, and so therefore x equals 1/2, okay? So remember, pi thirds is your 60-degree angle, essentially. So if you're talking about a 60-degree angle, x is going to be your 1/2. Now, if we do the sine of pi thirds, once again, sine is your y coordinate over your radius. Of course, our radius is 1, so sine just becomes y. And we know that the sine of pi thirds is square root of 3 over 2. And so therefore, this point here that represents if your angle t is a 60-degree angle, we've got your x coordinate is 1/2, your y coordinate is square root of 3 over 2. So that's going to be the coordinates on your unit circle. So with similar logic, we should be able to find the coordinates for pi halves. Now pi halves is going to be right here, right? What's the sine of pi halves? Do you guys remember?
1.
1. What's the cosine of pi halves?
0.
0. So you can see at 0, 1, so yeah. So your coordinates for pi halves are 0, 1. So of course we're going to remember our thing that all students take calculus. That'll help us here. So the cosine of pi fourths, hopefully by now you've all got that memorized, is the square root of 2 over 2. If we take the sine of 7 pi 6, excuse me, negative 7 pi 6, that's the same thing as the sine of pi 6. Now we're measuring this from the negative direction. So that's going to be all the way back into into quadrant 2. So that's going to be a positive value, 1/2. The tangent of negative 5 pi fourths. So remember, if we're measuring this in the negative direction, okay, this is pi, and then we're going to go pi fourths back here. So that also puts us in quadrant 2. And so that's going to be a negative 1. Because remember, the tangent of pi fourths is positive 1. And so anyway, questions on that, or are we good there? Okay. The secant of 5 pi thirds. Okay. So let's think about the secant. So secant is 1 over the cosine, correct? So let's talk about 5 pi thirds. So remember, we know that pi thirds is a 60-degree angle. I should put it there. 60-degree angle here. 5 pi thirds is going to be a, that's going to put us 6 pi thirds minus pi thirds. So that's going to put us down here in quadrant 4. We know that so I usually don't memorize the secant functions because I just figure out the cosine first. So this is 1 over the cosine, right? The cosine of pi thirds is, do you guys remember?
One half.
1/2. So now we're just going to take the reciprocal of 1/2, and that's going to be the value 2. Okay. Makes sense so far? All right, so the London Eye is the largest Ferris wheel in the world. I've actually been on the London Eye. Anybody else been to London? Been on the London Eye? Yeah, it's very big, tall, slow Ferris wheel. But London Eye is the largest Ferris wheel in the world with a diameter of 450 feet. It completes 1 revolution every 30 minutes. The height, h, in feet above the River Thames can be estimated by this function, 255 minus 225 cosine of pi t, where time is the minutes since the person has started the ride. So given this function here, how high would the person be at time t? Okay, where if time is 0, okay, what's the cosine of 0?
One.
It's 1, correct. Okay. So if at time 0, this whole thing is going to go to 0. So the cosine of 0 is 1. So 255 minus 225 would just be 30 feet. Okay. Now the next question is, how high is the person after 18 minutes? So let's pick on somebody here, such as we'll just start at the top. Brian Larson. Hopefully you can see my screen, even though I can't see you, but I know you have problems with your web camera. How would you figure out how high the person would be after 18 minutes?
I guess you just so I guess, can we back up just a tad? The 30 feet is, okay, yeah. So you just times that by the minute, right?
Yeah, so this is a function, so we can actually use functional notation. So this is the function right here.
Mm-hmm.
So all we need to do is find h of 18. Okay. So if that's your function, I'll try to keep, I can't keep them both on the same page very well. So maybe if I do this. Okay, now I can see them both on the same page. Okay, so h of 18 would be what?
Should be 255 minus 225, the cosine pi over 15 times 18.
Pi over 15 times 18. See, those are both divisible by 5, right? No, by 3.
By 3, yeah.
So this would be 255 minus 225 cosine. 6 pi fifths. Oh, we don't know what that one is though. 6 pi. Yeah, we don't. That's not one we have to memorize. I was hoping it would be a nice one. So we'll probably have to plug that one in our calculator, and we will. That's going to give us the value 437 feet. Okay. All right. So, any questions on that one? That wasn't too bad, was it? All right. Let's talk about the domain of the sine and cosine. Now, we've got this table 2.6, which is on page 160 in your book. So if you have the function y as the sine of t, you should know that your domain for the sine function is always going to be between -1 and +1. For your cosine of t, your domain is also going to be y is going to be, excuse me, I said the range, sorry. The domain is all real numbers. The range, y, is going to be between -1 and +1. With the cosine of t, once again, your domain is all real numbers. Your range is going to be between -1 and +1. With your tangent function, t can be any real number. And your range is also going to be any real number, but the problem is we have some places where the tangent of t is undefined, okay? It's undefined at basically pi halves and any multiple of pi halves. And so what we've done here is 2n plus 1 are your different multiples of pi halves. So at any multiple of pi halves, your domain is undefined. Your range can be all real numbers. Now the same thing works with the reciprocal functions. Your cosecant is going to be undefined. So as we think about this, when we're doing reciprocals, you can't have 0 in the denominator, and so your reciprocal function cosecant, your t is undefined at multiples of pi. Your range, y is greater than or equal to 1, or y is less than or equal to -1. With your secant, once again, you're going to have problems with multiples of pi halves, and so we've got 2n plus 1 gives you your multiples of pi halves. Once again, your range, y is greater than or equal to 1 and less than or equal to -1. And t can be any real number except for multiples of pi halves. Your cotangent, t can be any real numbers. It's undefined at multiples of pi. And so your range is also all real numbers. So the one thing that I will mention to you is this is going to be a very important table, especially when we get into graphing functions. So you're going to definitely want to keep this in mind. So maybe I'll do this to make that. Okay, so I've just said all that. Okay, let's talk about odd and even functions. Sine is an odd function. Okay, so I don't know if you guys remember that from Math 1050. An odd function is f of negative x equals negative f of x. So another way to think about odd functions are they are symmetric about the y-axis. Okay. No, sorry. Not true. The even functions are symmetric about the y-axis. The odd functions are symmetric about the origin. And so this is going to be more, this will probably make more sense when we actually start graphing these functions. But you've got this f of minus x equals minus f of x. Okay, so I want to show you guys, even though it's odd to me that the book is introducing this, because I think this will make a lot more sense when we actually start graphing sine functions. In fact, let me see something here. I'm going to introduce something else to you. Graph sine of x. Okay, so this is the sine function of x. And so one of the things you'll notice here, this is going to be your sine function. I don't know why we don't teach you this earlier, teach you in this section, because one of the things that's interesting, you can see here, so this is going to be one period, and we're going to talk about how this graph is. I'm kind of introducing you some new stuff, but I think it's easier to understand even and odd if you can look at the sine function. And so this is one revolution, and so you can see that this is symmetric about the origin. So this first peak, if you go on the left side of the y-axis, is down here, and then this peak is symmetric with this peak here. And so that would be an example of an odd function. If I have the cosine function, one of the things that you will notice here, okay, so this is the cosine function. You can see that this is symmetric about the y-axis, because this is a big almost V-shaped thing here, and this is a V-shaped thing here. And so this would be an example of an even function. It's symmetric about the y-axis. So that's even. This is an odd function. It's symmetric about the origin. And heck, let's just do the tangent function while I'm at it.
Really
We're going to learn all.
Last one.
Uh-huh.
Are you talking about the points on the x-axis?
Points on the x-axis. What do you mean by that?
Just where, I guess, the point of origin. Are you meaning? I just don't understand what you mean.
I understand what you're saying. Okay, so have you guys ever seen Perfect Trigonometry by Numberphile on YouTube? If not, it's fine. So basically, like the cosine is the position at which where a point is. Say you got a circle, right? And say right in the middle, right where the y-axis is, there's a point starting at the top of the circle, right? the cosine tracks where the point is along the y-axis as it moves along the circle. The sine tracks the point as it moves along on the x-axis, I believe. It might be, I think it might be different, but yeah, basically as a point moves along a circle, this graph indicates where that point is, where it's going through pi, 2 pi, so on and so forth.
Yeah, let me just say this. I understand what it's Texas. Your name's Texas, right?
Yeah.
You said, and I'll explain that in a minute. But the easiest way to think about an even function, if I took a piece of paper and I folded it along the y-axis, you've got a mirror image on the left as you do the same mirror image on the right. And so that's what I mean by an even function. An even function is always symmetric about the y-axis. If I folded my paper in half right on the y-axis, these are mirror images of each other with the cosine function. Does that make sense?
Yeah, that makes sense.
Okay,
Thanks.
so that's what I mean by an even function. When we go to the sine function, okay, it's not symmetric about the y-axis. I would, instead of folding it along the y-axis, I could fold it along, I could actually fold it along this 45-degree angle, and then it would be a mirror image across the y equals x line, or actually, I guess this line here, y equals x line. So it's symmetric about the origin. So for example, so this point here, let me back up, because this kind of ties back to what Texas was saying, and I'm kind of, we're going to learn this in a future section, so if you don't understand it, don't be too concerned. But what Texas was just trying to say, if we go back to, let me go back to my notes here for a second. Okay, so when we were talking about this here, remember when we're talking about the unit circle, okay? So this is 0, 1, this is 1, 0. If we were to plot all of these points along here, let's see, so if my theta is pi 6, excuse me, my theta is pi 6, then this is going to be, let's see, pi 6, 1/2 square root of 3 over 2. So if we were to plot all of these points, so all of these single points here, pi thirds, pi fourths, pi 6, etc., everything, if we were to plot those, that's going to give it, let's see, that's going to give us this sine wave. Okay, so if I plot, so this is pi halves and the value 1. And this is 3 pi halves, the value of -1. The sine of pi is 0. The sine of 2 pi is 0. The sine of -pi is 0. So if we were to take and plot all of these points, so if I pick this point xy, if we were to plot it this way, this becomes the sine wave. And so that's kind of what Texas was illustrating with what his explanation was. And so that's where we get this sine wave function. And it works the same way if we plot the cosine function. Okay. I just think it's a little bit easier to kind of see this. Clearly, especially the cosine function, clearly you can see if I folded the paper along the y-axis, I'm going to get a mirror image. So that's going to be an even function. And the sine function is an odd function. And so if I folded that along the x equals y line, then that's going to be a mirror image of each other. Now, the last one that I wanted to point out here was the tangent function. And I'm jumping ahead out of here. But you can see this is not symmetric about the y-axis, but it is symmetric about the origin. If I were to fold along the y equals x line, then this diagonal line here, if I put a diagonal line here, y equals x, then you could see I could fold this and it would be a mirror image of each other. So the tangent function is also an odd function. So just as a reminder, because you probably haven't had even and odd functions for a while. So sine is an odd function because f of minus x equals minus f of x. Cosine is an even function because f of x equals f of minus x. And tangent is an odd function also because f of minus x equals minus f of x. Okay. So, and maybe I should go into a little bit more detail. So now let's do this one. This is where I wish I had a piece of paper, but we're going to try to do this in Excel. I think this will work. Okay. So now the question is x times the tangent of x odd or even? Okay. So remember, odd says that f of x equals f of minus x. And even, actually I said that backwards, didn't I? Sorry, that's even here. Even. Odd says minus f of x equals f of minus x. Okay. So one way to think about this, so we've got a function x times the tangent of x. Okay, so if this, so f of x, let's say the f of x equals tangent x times the tangent of x. Okay. Now let's find f of minus x. Minus x, okay? So in this case, who can help me with this? Let's pick on Brody. Brody, can you help me with this? Can you help me find, if f of x equals this function here, can you help me find f of minus x?
Yeah, so it would be negative x times tangent of negative x.
Perfect. Okay, so let's think about this for a minute. In fact, let's go back to this for a minute. Okay, so the tangent of negative x. So if this is x, so the tangent of x is positive. The tangent of negative x could either be positive or negative depending on which quadrant I'm in, correct?
Yeah.
So, so if the tangent of x, so if x is positive, if x is positive, then your tangent of x is positive. If x is negative, it's hard to tell if your tangent of x is positive or negative, correct? So let me look here. Let's talk about this. Okay, so an odd function, f of x is minus f of x. So if I put a negative x in here, I'm going to have negative x minus the tangent of negative x. So let me put a little thing here. So if I get rid of my parentheses here, I've got negative x plus the tangent of x. And so I was trying to show it even. So it's not, basically what I've shown here is it's not even, okay? Now with odd, we have to show, with odd we have to show is minus f of x equal to f of minus x. Oh, I put an equals there, but that's supposed to be a minus. Okay, and so in this case, you can see that f of minus x equals minus f of x. And so therefore the function is odd. Does that make sense? I know this odd and even stuff is kind of goofy. All right, let's talk a little bit about some trig identities. This is from page 163. So you guys know that the sine of t is 1 over the cosecant, the cosine of t is 1 over the secant, and the tangent of t is 1 over the cotangent. So another thing that we could do is we could refer to the tangent. Remember that especially in the unit circle, tangent is y over x. And since we're in the unit circle, we could write y as the sine of t and x as the cosine of t. So the tangent of t can be written as the sine of t over the cosine of t. And then conversely, by the same logic, the cotangent of t is the cosine of t over the sine of t. We also have what we refer to as the Pythagorean identities, okay? So this is something you guys are going to want to you're going to definitely want to memorize. Hopefully you've already got that memorized, okay? This is probably new today, and this is new today, but hopefully that's not too bad. In the unit circle, remember that x squared plus y squared equals the radius squared, which is 1. And so the Pythagorean identities are cosine squared of t plus the sine squared of t equals 1. And so you'll want to memorize this as well. You can think of this as x squared plus y squared equals 1. So that's, you know, just your triangle identity. 1 plus the tangent squared equals the secant squared. And 1 plus the cotangent squared of t equals the cosecant squared of t. Now, let's think about this for a minute. You can also utilize the tangent squared as the sine squared over the cosine squared of t. And the secant squared, you can think of that as 1 over the cotangent of cosine of t, excuse me, squared. So anyway, these are some Pythagorean identities. You'll probably have some homework problems dealing with that. This is example 7 out of the book. So if t is in between pi halves and pi, so let's think about that for a minute. That means we're in quadrant 2. Write the tangent in terms of the sine of t, okay? So remember, according to our ratio identities here, the tangent of t equals the sine over the cosine. And now we can solve the Pythagorean identity. So the idea, here, let me do it this way. I don't want to, I think it might be easier if I do this. So write the tangent of t in terms of sine only, okay? Now, we know that the tangent of t equals sine of t divided by the cosine of t. Because that was one of the identities I gave you, right? Okay, so I've converted the tangent of t as the sine over the cosine, but I need to get rid of the cosine now. Does that make sense? Okay. Now, one of the other identities we had was the sine squared of t plus the cosine squared of t equals 1. Okay. What I can do is I can solve this for the sine squared. So if I subtract the cosine squared of t from both sides, okay, that's going to give me the sine squared of t equals over here now I've got 1 minus the cosine squared of t. Okay. Now, if I take the square root, okay, of both sides. Now you can see that the sine of t equals the plus or minus square root of, I need to put this here, 1 minus the cosine. Oh, except for I think I did, no. You know, I did this backwards. I shouldn't have solved for the sine squared. I should have signed for the cosine squared. Here, let me change this. Cosine squared. So I'm going to subtract, I'm going to subtract the sine squared from both sides. All right, so now this is going to be the cosine squared of t equals 1 minus the sine squared. Now I've got the cosine of t equals the plus or minus square root of 1 minus the sine squared of t. Are you with me so far? Okay. Now the nice thing, since I've solved this for the cosine, I can now substitute this in where this was here. So I've got the tangent of t equals the sine of t, that's my numerator. And now the problem is I've got a plus or minus here. Now let's think, now according to my example here, I'm looking where t is between pi halves and pi. So going back to here, let me just open up a new page. Okay. I am in quadrant 2, right? So in quadrant 2, okay, all students take calculus. Okay. Now, so in my problem, I've limited myself to quadrant 2. Okay. So when I'm talking about the quadrant 2, okay, when I'm talking about the sine function, is the sine function positive or negative in quadrant 2?
Positive.
It's positive, okay? So in quadrant 2, I can actually get rid of this negative because in quadrant 2, it's always going to be positive, okay? So in this case, I've now written the tangent of t is the square root of 1 minus the sine squared. 1 minus the sine squared of t. Okay? And that's a... And so now I've changed the tangent of t. I've rewritten the tangent of t as simply a ratio of the sine of t. Does that make sense? Okay. So that is example 7 in your book. And so when t is between pi halves and pi, you can rewrite your tangent as, oh, except for why do they have a negative in there? Oh, because the cosine's negative. Sorry, I was talking about the sine. The cosine is negative, that's right. So actually, this is the negative square root. Yeah, that's right. Because yeah, I'm substituting the cosine in here. Cosine is negative in quadrant 2. So that's where we get the negative from. Okay. Does that make sense? All right, let's do another. And this is kind of where we start getting into trig identities, and this can be a little tough. But we want to write 1 plus the sine squared plus 1 plus the cosine squared as a single term. Okay. So here I'm going to open up a new page here. Okay, so 1 over the sine squared of t. I'll try to make that look like a fraction. That's probably the best way. Plus 1 over the cosine squared of t. Okay, so we're going to write this as a single term. Okay. All right. So we need to get a common denominator. Maybe I'll center that so it looks a little better. So how would you guys go about getting a common denominator? Let's see here. It must be Cameron Daly's turn. How would you get a common denominator?
Times the 1 sine squared of t by cosine of t, and then times the 1 cosine squared of 2 by sine squared of 2.
Oh, yeah, they're both sine squared and cosine squared. So we're gonna multiply the left side by the cosine squared of t. And this one over here, we're going to multiply by the sine squared of t, just like you said. Okay, so my common denominator is going to be the sine squared of t times the cosine squared. Okay. So cosine squared of t times 1 is simply the cosine squared of t. And we're going to add that to sine squared of t times 1 is the sine squared of t. Okay. So now I've got this nice fraction here. Do you guys remember from one of our Pythagorean theorem identities, what does the cosine squared of t plus the sine squared of t equal?
1.
1. So this becomes 1 in the numerator, and my denominator is going to stay the same. Sine squared of t plus cosine squared of t. Okay? So there you have it. So that's how you would do simplify that little trigonometric expression. Okay. All right, what are we doing on time? Okay, we're actually doing pretty good. Okay, so we're going to talk about periodic functions and periods. And to some degree, let me go back here. And I don't know why we don't introduce to you these trigonometric functions, but one of the things you'll notice here, since I've got the tangent of t here, if you repeat the tangent function a bunch of times, as in this bottom graph, you can see that this graph, there's actually asymptotes in between these two. There's an asymptote here, there's an asymptote here, there's an asymptote here, et cetera, et cetera. So this is what we're going to refer to as a periodic function, because the graph just repeats itself over and over and over. And this works the same with the sine. You'll see here that the sine function repeats over and over and over, and the cosine function repeats over and over and over. Okay, this is your cosine function. In fact, one of the things that we will learn, not necessarily today, the cosine function and the sine function are basically the same function shifted 90 degrees. But these are what's known as periodic functions. So another way to think of a periodic function that you're all used to, time of day repeats every 24 hours. So if f of t represents the present time of the day, then in 24 hours, you can express the function of time plus 24 equals the current function of time. So, 24 hours from now, it's currently 9:11 a.m. In 24 hours, it will be exactly 9:11 a.m. again. And so this is what we're going to refer to as a periodic function. It repeats itself over and over and over. So a function is periodic if there exists a positive constant p such that f, the function t plus p, equals the original function again for all t in the domain. And so the smallest p is called the period of your function f. So the unit circle is a periodic function that repeats itself every 360 degrees or every 2 pi. And any point on that circle repeats as well. And so your first point, xy, is the cosine of t times comma sine of t. And then it's going to repeat every 2 pi. So the cosine of t plus 2 pi and the sine of t plus 2 pi. So this is the same for your cosecant and your secant as well. Oops, didn't mean to do that. Okay, so the tangent and cotangent functions are also periodic. They repeat every pi units. So, and I kind of showed you that on the previous graph there. So your tangent repeats every pi units. Your cotangent repeats every pi units. For your sine and cosine, they repeat every 2 pi units. And so your sine function is going to be repeating every, you can think of this as every 360 degrees. So t plus 2k, where k is some integer, it's going to, your functions are going to repeat. So sine, cosine, secant, cosecant repeat every 2 pi. Tangent and cotangent repeat every pi. So example 5 gives a little bit more information on that. Let's see, if we sketch the unit circle and let P be the point on the unit circle, such that if I take a point PXY, if I draw a diameter, then that's going to be your endpoint Q on the unit circle. For every point on XY, then Q of minus X minus Y is also a point on the line. And because it's the diameter, then the length of the arc is pi. So we're using the unit circle. So this arc length is going to be the same as your diameter. So your wrapping function says that your sine of t equals y, your sine of t plus y equals minus y, and thus the sine of t plus pi equals the minus sine of t. So we probably could have used that a little bit earlier when we were talking about odd and even functions. So anyway, I think that's all I have. So do you guys have any questions for me? We'll let class out a little bit early today, unless you have questions. We've got a few more people here.
So will the homework be due Monday morning?
Yeah,
tomorrow morning.
Homework will be due Monday morning, unless you want to do tomorrow.
Okay.
Well, most people like the weekend. So yeah, you can do it. I'll get your homework up within an hour or so, just like I normally do, and then you can either get it done today and have it done by tomorrow, or for you procrastinators out there, you can wait until Monday morning. If I were you, I'd get it done now so you can enjoy your 4th of July weekend. So this is a weird semester. Usually, normally we miss either the 4th, or a lot of times we miss the 4th and the 24th, and this time we're not missing either one. So I guess that's good for not missing class time, but it's kind of weird. I don't think I've ever had a summer semester where I have not missed both the 4th and the 24th of July. So, all right. So quiz 2.4 is going to be due on Monday. So is your homework. And of course, let me know. By the way, I did find out there is no online homework option for this book. So that was sad. So I guess maybe I should do a poll question. Would you rather make the quizzes worth 10% of your grade, or would you like to leave it as is, where you can just tell me on your honor if you've done your homework?
I would say as is.
Leave it
As is.
As is.
I'd
Any
say as
objectors
is.
out there? That's kind of what I thought. Okay, well, I'm just going to trust you guys. We will certainly find out on the test if you understood your homework. So if you want to say you did your homework and get all the things, I'm going to find out next Thursday on the test when you fail the test. So please make sure you're doing that. I will post the homework. I think everybody said, well, actually, let me ask this. Who does not have the book yet?
I still don't have the book.
Okay, I saw 2 raised hands, Josue and Graham. And
Mine
then
should be coming later today.
Okay, so we've got at least 4 people that don't have the book. Okay,
It'll
so
be
I will
here today, though.
Today? Good. Okay, I will post 2.4 homework. Hopefully I won't have to do that anymore. But I will post that today. And yeah, so we'll just keep it on as is. Remember, we've got a test next week on Thursday. So let's see, we covered 2.4 today, 2.5 Monday, 2.6 Tuesday. We'll have a review on Wednesday, test on Thursday. So we won't actually meet Thursday. I will just open up the test for you. Let me mention, some of you still have not taken the Proctorio quiz. Please take that today, because I'm going to hate that you can't take the test, because you need Proctorio for the test. So if you have not taken the Proctorio quiz, get that done today. I don't care if it's late, but I need it to be done, because I don't want to have a problem on Thursday when it will absolutely be required. It's a 1 question. Can you see this question? I think is what the question was. Can you see this question? Yes. Okay. You're good to go. So, all right. Well, I'll let you guys go if you guys want to stick around.
Really quick, I had a question about the test.
Okay.
So is it only open for that specific window?
Yeah, unless you have a reason
mornings,
not to take it at that
a lot
time.
of mornings I have to work in the morning. That's why I'm not here half the time, and I work at 9. So how would that work if I have to work?
Well, if you want to, if you prearrange with me, I can let you take it at a different time. But I'd like, unless you have a reason like work or something, just send me an email and say, hey, I got to take it at 10 o'clock or something. I'll open it from 10 to 11:30 for you
Okay.
only. But yeah, most of the class, unless you have a reason to miss it, or even if you're working all day, if you want to take it at night, whatever, just tell me what time you want to take it, and I will open it up for that 90 minutes.
Okay. Sounds good.
Yeah. So, any other questions you guys have?
No.
All righty then. Well, We can end class now. I know Texas, I think you like to meet now, and that's fine. I'm going to stop recording. And if you guys want to hang out in the room and keep talking, then that's perfectly fine. And if you want to use this room, like I know some of you have to work, if you want to open it up at 7 o'clock, just click on the same link and it should work fine for you. I think you do have to be not a guest, though. I know some of you have a guest next to your name. That means you're not using the Teams, and usually you have more problems with that. But either way, I don't care. So, all right, we'll see you all on Monday.
All right.
Thank you.
Mm-hmm.